discuss how to find out the hybridization of any molecule or the ion. Okay, and how to calculate bond pair of electrons and the lone pair of electrons. In the last video, we have discussed about the types of hybridizations and the geometries also. If you didn't watch that video, I'll provide the link in the description box. You first go to that video and watch that video, then come back to this video. Then this video will be more clear to you. Okay. So now we'll start with some examples. So here the first we'll take BeCl2. How to find out the hybridization? If at all this is given to you, how to find out the hybridization? First you identify which is the central atom as usual procedure. So here central atom belongs to which group? First point, you must identify how the central atom belongs to which group. So here it is beryllium, it belongs to second group. So here 2 cross marks are 2x as it belongs to second group. So here for each cross mark, one chlorine means one surrounding atom, whatever the atoms attached to that chlorine. So here it is second one. So here 2 bonds, one bond, second bond, first bond, second bond. Okay. So here how many bond pair of electrons? 2 bond pair of electron. So in the last video we have discussed if 2 bond pair of electrons, what is the type of hybridization? So here it is sp hybridization, 1 plus 1 s orbital and 1 p orbital, altogether 2 bond pair of electrons. So 2 bond pair of electrons means here it is sp hybridization. What is the type of hybridization? It is sp hybridization. So with the geometry of, if at all it is a sp hybridization, so the geometry will be like this, linear geometry. Here 2 chlorine atoms and a central atom beryllium with a bond angle of 180 degrees. This is how here from this you can find out what is the hybridization is. Okay, and how many bond pair of electrons are there and how many lone pair of electrons are there from this procedure. Here there are no lone pairs. So here you can find out the geometry if you know what type of hybridization it is. Okay, next second example. Okay, so here you calculate hybridization for NH3, BF3. First you find out hybridization for BF3, boron. So here boron trifluoride means here boron belongs to which group? Third group. So 1, 2, 3. How many fluorine atoms are there? 3. 1, 2, 3. So how many bond pair of electrons? 3 bond pair of electrons. 3 bond pair of electrons means what is the type of hybridization? If it is 2, it is sp2 hybridization. 1 s orbital and 2 p orbitals, altogether 3 bond pair of electrons. If 3 bond pair of electrons means here sp2 hybridization. If sp2 hybridization, what is the geometry? It is linear geometry and it is trigonal planar geometry. Trigonal planar geometry with a bond angle of here B, F, F, F with a bond angle of 120 degrees. Clear? So here next you come to this nitrogen. Nitrogen belongs to which group? It is the central atom here. Hydrogen and fluorine cannot be central atoms. I told you while discussing the Lewis dot structures also. So here nitrogen, and the nitrogen belongs to fifth group. So 1, 2, 3, 4, 5. So here how many hydrogens? 1, 2, 3 hydrogens. So how many bond pairs? 3 bond pair of electrons. And here you left with 2 electrons. These exist as a lone pair. Now how many lone pair of electrons? How many lone pair of electrons? Here 3 bond pair of electrons plus 1 lone pair of electrons, altogether 4. Altogether 4. So what is if it is 4? What is the type of hybridization if it is 4? So here clear. First you find out the central atom belongs to which group. So here it is beryllium belongs to second group two chlorine atoms attached, two bond pair, 2 means sp hybridization with a geometry, linear geometry with a bond angle of 180 degrees. Similarly, this procedure you can adopt for any molecule or the ion to find out the hybridization or the bond pair of electrons. Okay. Now here comes to BF3, it is trigonal planar because 3 bond pair of electrons and the hybridization is sp2. And coming to this NH3, okay. So here 4 means here, what is the type of hybridization? It is sp3 hybridization. What is the type of hybridization? It is sp3 hybridization with a geometry, tetrahedral geometry. 4 means it is tetrahedral geometry with a bond angle of 109 degrees 28 minutes. So here nitrogen, hydrogen, 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 lone pair. Here the geometry is tetrahedral. Geometry is tetrahedral and the shape is pyramidal. So we'll discuss that later. So here the geometry is tetrahedral geometry. Okay. So here NH3, first you identify the central atom belongs to which group. So here it is 5th group. So 5 cross marks, 3 hydrogens, so 3 bond pairs. 1 will be 2 electrons reside as a lone pair. So altogether 3 bond pair of electrons plus 1 lone pair of electron. 4 means sp3 hybridization with a geometry of tetrahedral. Okay. Here the bond angle is less than 109 degrees. The reason we'll discuss in the next video. Okay. Now here you concentrate mainly on the mainly how to calculate hybridization and how to calculate bond pair of electrons, lone pair of electrons, and what is the geometry. Okay. Now we'll discuss another example. So if at all it is CH4. Carbon belongs to which group? 4th group. 4. So here 4 hydrogens, no lone pair of electrons. So here 4 bond pair of electrons means what is the type of hybridization? sp3 hybridization. Okay, with a geometry of tetrahedral. So if at all CH4 molecule is given to you, how many bond pair of electrons? Simply 4 bond pair of electrons with 0 lone pairs, and the hybridization is sp3 and the geometry is tetrahedral. Next, another example. This is 4th or 5th example, whatever it may be. Okay, and next, if at all, next example, PCl5. Phosphorus belongs to same 5th group, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So how many bond pairs? 5 bond pairs. 5 bond pair of electrons means what is the type of hybridization? It is sp3. Means here 4 sp3 dehybridization. Clear? sp3d. 5 means I told you already in the last video. 5 means one triangle, means here it is the central atom here, and corner atoms, these we call as equatorial atoms, and one above the plane, one below the plane, one atom. So chlorine in middle, in the center it is phosphorus, chlorine. Whatever chlorines occupy the corners of a triangle, we call them as equatorial atoms, equatorial positions, and these are axial positions. This is here, if you consider this as a, all this I have discussed in the last video. If you didn't watch that video, please first watch that video. Okay, here it is a triangle. If you assume this as a triangle, one atom here, one chlorine atom, this is the chlorine atom above the plane, and here this is the second chlorine atom below the plane. So these two are these two atoms are perpendicular to this triangle. So the bond angle will be 90 degrees. And here in the triangle, the bond angle is 120 degrees. Clear? So here PCl5, phosphorus belongs to fifth group. 5 bond pair of electrons with 0 lone pairs. 5 means sp3d. 3 plus here 1 plus 3 plus 1. sp3d hybridization. This is the geometry, trigonal bipyramidal geometry. What is the geometry? Trigonal bipyramidal geometry. Clear? Super clear? Okay. We'll discuss another example. So next, SF6. Next molecule, SF6. Sulfur belongs to which group? Oxygen, sulfur. So oxygen, sulfur belong to same group. So sixth group. So 1, 2, 3, 4, 5, 6. 6 fluorine atoms. How many bond pair of electrons? 6 bond pair of electrons. So 6 means I told you it is square bipyramidal or octahedral. So here 6 means what is the hybridization? sp3. sp3 means 1 plus 3, 4. Here we have 6 bond pair of electrons. So we left with 2. So it is D2. sp3 D2 hybridization with the geometry of 6 means here 4 plus 2. Here in the last case PCl5, 5 bond pair of electrons, 3 plus 2. Here it is 4 plus 2. Okay. So here it is the central atom S. These occupy 4 corners of the square. You assume this as a, this square is like this. Okay. One atom below this, one atom above this square and one atom below this square. So here like this. This geometry is called as a square bipyramidal geometry or octahedral geometry. What is the bond angle? Here it is in the square, each angle is 90 degrees, and here it is you assume this as a square. One is above the plane, one atom is above the plane and another atom is below the plane. So here it is perpendicular to this plane. So here 90 degrees again. These are also 90 degrees. So altogether the bond angle is 90 degrees. If we draw, it is a square bipyramidal or octahedral. Okay. So SF6 sulfur belongs to 6th group. 6 cross marks. Each atom, you attach each atom to one cross mark like this. So 6 bond pair of electrons altogether. sp3d2 hybridization with the geometry of 6 means 4 plus 2. I told you 5 means 3 plus 2. Okay. And 3 means it is trigonal planar. 5 means 4 means tetrahedral. Okay. In the last video I have discussed clearly. Okay. And here it is 6 means octahedral or square bipyramidal with a bond angle of 90 degrees. Clear? Clear? Okay. Next we'll discuss another example. IF7. Interhalogen compounds. So here iodine belongs to which group? Fluorine cannot be a central atom and the central atom should be least in number. And here it belongs to 7th group. So 7 cross marks, 1, 2, 3, 4, 5, 6, 7 cross marks and 7 fluorine atoms. So we attach each one fluorine atom to this cross mark. So how many bond pairs altogether? 7 bond pair of electrons. So 7 bond pair of electrons means here if it is 5 bond pair of electrons, 5 bond pair electrons, here 3 plus 2. Here 2 atoms will be 2 atoms, one will occupy above the plane, another will be below the plane of a triangle. 3 means triangle. It is a trick I am telling you. So here if at all it is a 6 bond pair of electrons. So here it is 4 plus 2. 4 means square and remaining 2 atoms, one above the square and one below the square. and 7 bond pair of electrons, it is 7 means here it is 5 plus 2. This is the super trick. So if you remember like this, here it is 5 plus 2. 5 means pentagon. Pentagonal bipyramidal. On the pentagon, one atom above the plane of the pentagon and another atom below the plane of the pentagon. So 5 plus 2. If 6 bond pair of electrons, 4 plus 2. 4 means it is a square, you know. So 4 atoms occupy, including the central atom, including the central atom. And here 4 plus 2, 1 atom above the plane, 1 atom below the plane. 5 means 3 plus 2. Clear? This is the super trick. And here it is 7 bond pair of electrons. So 5 plus 2. 2 is common. Okay? Means 2 atoms, 1 above the plane, 1 below the plane. So here it is, what is the hybridization? First you write sp3 means 1 plus 3, 1 s orbital and 3 p orbitals. Here 4, we left with 3. So sp after that d3. So here altogether 7. So what is the hybridization? sp3d3. 7 bond pair. 7 means 5 plus 2. 5 means it is pentagon. Here it is the central atom. Central atom, what is the central atom? I. So F's at the 5 corners of a pentagon. And one atom above the plane and another atom below the plane. Here one fluorine, another fluorine. These two are perpendicular to the plane of the pentagon. So here these two make a bond angle of 90 degrees. And here in the pentagon, each angle is 72 degrees. So what are the bond angles here? 90 degrees and 72 degrees. Clear? Clear? Super clear. So here, if at all 5 bond pair of electrons, you split as 3 plus 2. 6 bond pair of electrons, 4 plus 2. 7 bond pair of electrons, 5 plus 2. You applied this trick anywhere. Okay? For the simple molecules and the ions. So here, pentagon. Each pentagon, it makes a bond angle of 72 degrees. Here 2 atoms. Here 2 means 2 atoms, 1 above the plane, 1 below the plane. They are perpendicular to the plane of a pentagon. Here also, here in these 3 cases, these 2 atoms are perpendicular to the plane of that. Here it is 6 means here these 2 atoms are perpendicular to the plane of a square. These 2 are perpendicular to the plane of a triangle. These 2 are perpendicular to the plane of a pentagon. Like that. Okay. And this is about IF7. Now we will discuss if at all any positive species, positive ion, cation and anion is there, how to find out the hybridization. Okay. If at all any cation is given, like ammonium ion, NH4+, how to find out hybridization for the cation? So here same procedure. Here nitrogen, first you identify the central atom and you just identify the atom belongs to which group. So here nitrogen, it is, what is here nitrogen belongs to 5th group. So here 1, 2, 3, 4. Here as it belongs to 5th group, here plus indicates loss of 1 electron. So 5 minus 1. So only 4 cross marks you place. Got it? Here in chemistry, plus indicates deficiency, means loss of electron. One electron, it lost 1 electron. So here group number 5th group, 5 cross marks. So minus 5 minus 1. So now hydrogen, 1 second, 3rd hydrogen, 4th hydrogen. So how many bond pairs? 4 bond pair of electrons and the hybridization is sp3 hybridization. Clear? If any cation is there, for cation you make a note. For cation, same procedure. For cation, group number -1. Group number -1. For anion, group number, anion means electrons gained, group number +1. You make a note of these 2 points. So here now you find out for CO3 2-, just pause the video and try to solve this one. CO3 2-. Okay. Now carbon belongs to which group? 4th group. So 4 plus, here anion, here 2 minus means 4 plus 2. So 6 cross marks you place. 1, 2, 3, 4, 5, 6. And here I am going to tell you another point. Here if at all oxygen is there, here one oxygen you attach with 2 cross marks. One oxygen you attach with 2 cross marks. One oxygen you attach with 2 cross marks. Altogether, how many bond pairs are there? 3 bond pair of electrons. So 3 means what is the hybridization? It is sp2 hybridization. Clear? So here these 3 points you have to. For oxygen, you attach 2 cross marks to one single oxygen. Okay. And here if cation is there, group number, central atom group number -1. For anion, central atom group number +1. And here if oxygen is there, like this. Clear? Super clear? Okay. We'll solve some more examples. Okay. So if at all it is ICl4 minus. So what is the hybridization of this one? And how many bond pair of electrons and lone pair of electrons are there, and what is the geometry? Find out, try to find out for this one. So central atom, iodine, belongs to 7th group, 7 cross marks, 1, 2, 3, 4, 5, 6, 7. Okay. Central atom, here it is minus is there, anion, central atom group number +1. So 1, 2, 3, 4, 5, 6, 7, 8. And how many chlorine atoms? 1, 2, 3, 4. Okay. For oxygen, it is a bivalent. That's why we have attached 2 cross marks to one oxygen. Here all these are monovalent. 1 bond each. So here how many bond pair of electrons? 4 bond pair of electrons. Okay. How many lone pairs? Okay, 1, 2. 2 lone pair of electrons. So altogether 6. 6 means what is the hybridization? sp3, 1 plus 3, 4. We left with 2. It is D2. sp3 D2 hybridization. sp3 D2 hybridization. Clear? Clear? sp3d2 hybridization means what is the geometry? 6. 6 means here. 6 means here. What is the geometry? Square, bipyramidal or octahedral. Geometry is different from shape. Okay. Geometry means here in the next video I will discuss about the geometries and shapes clearly. Here in this video you mainly concentrate on how to find out bond pair of electrons, lone pair of electrons, and what is the geometries and what is the hybridization. Okay. And next example. In the next example I have taken oxygen. So if at all any confusion is there, that will be clear. So here silicon belongs to 4th group. So here it is an anion. So group, central atom group number +2. 2 minus is there. So 6. 6 means 1, 2, 3, 4, 5, 6 cross marks. And here 3 oxygens are there. So each oxygen 2 cross marks. So how many bond pair of electrons? 3 bond pair of electrons. Clear? 3 means what is the hybridization? sp2 hybridization. sp2 hybridization with the geometry of trigonal planar geometry. Clear? Here central atom group number, if this is an anion, +2, 6 cross marks, oxygen 2 cross marks, only for oxygen. Okay. 3 bond pair of electrons, it is the hybridization, and the geometry is trigonal planar geometry. Okay, we'll discuss one more example. fluorides I have taken. Here it is a xenon fluoride and here it is xenon oxyfluorides. Okay. So here xenon belongs to noble gases. Xenon belongs to 8th group. 1, 2, 3, 4, 5, 6, 7, 8. So 2 fluorine atoms. 1, 2. How many bond pairs? 2 bond pair of electrons. How many lone pairs? 2 make 1 lone pair. 2 make 1 lone pair. So 3 lone pair of electrons. So altogether 2 plus 3, 5 bond pairs. Bond pairs plus lone pairs. So altogether 5. So what is the hybridization? It is 5 means sp3d hybridization. If it is an sp3d hybridization, 5 means it is trigonal bipyramidal geometry. Clear? Okay, after watching this video, this concept should be super clear to you. Okay, sp3d trigonal bipyramidal means triangle like this. Okay, let's see F2. If now for this one you find out the hybridization, xenon belong to 8th group. 1, 2, 3, 4, 5, 6, 7, 8 cross marks. So here oxygen, 2 oxygens are there. Okay, and remaining fluorines 1, 2, 3, 4. Altogether 1, 2, 3, 4, 5, 6 bond pair of electrons. 6 bond pair of electrons with no lone pair. So the geometry is 6 means 4 plus 2. 4 plus 2. So here the geometry is octahedral or square bipyramidal. Clear? We'll discuss another example if you want. NO2 minus BrF5. Now tell me what is the hybridization involved in these two. Nitrogen belong to 5th group. 5 plus 1, 6. 1, 2, 3, 4, 5, 6. 2 oxygen atoms. 1 lone pair. 2 bond pair of electrons. 1 lone pair of electrons. So altogether 3. 3 means sp2 hybridization. Trigonal planar geometry. Clear? Next BrF5. Bromine belongs to 7th group. 1, 2, 3, 4, 5, 6, 7. So 5 fluorines. 1, 2, 3, 4, 5. 5 bond pair of electrons with 1 lone pair. So altogether 6. 6 means sp3d2 hybridization. It is octahedral or square bipyramidal geometry. Clear? Okay. In the next video, we'll discuss many examples and we'll discuss about how to find out what is the difference between geometry and the shape of the molecules or the ions. Okay. Till now, bye.